All right, guys, let's talk about this final review. On row 1, we're just combining like terms. So we got 3x and 5x on the same side, so we're going to say 8x minus 2 equals, and on the right side we got 8x and 7x on the same side, so 8x minus 7x is x plus 54. All right, I'm going to move my x's to the left, so it's going to be 7x minus 2 equals 54. Add 2 to both sides, you got 7x equals 56. All right, and then divide the 7, you get x equals 8. All right, on number 2, we're going to do this thing called fraction busting. So 4 goes into 8. So 8, if I was going to get a common denominator, it would be my common denominator. So I'm going to multiply the entire thing by 8, and that's going to get rid of my fractions. And whether you were to work with the fractions or do what I'm about to do here, you get the same answer. So in my opinion, I'm going to get rid of the fractions. So 4 goes into 8 2 times. 2 times 1 is 2, so I got 2x. 8 goes into 8 one time. 1 times 3 is 3, so I got minus 3x equals, and then because the 4 on the right side doesn't have a denominator, it's just straight multiplication. 4 times 8 is 32. All right, so that's going to be negative x equals 32. X equals negative 32. All right. Now you can do the same thing here on number 3, but you want to multiply by powers of 10. So you want to multiply by 10, 100, or 1,000, depending on how many decimal places there are. All right, so I have 2 decimal places with 0.86, 1 decimal place with 0.9, and 2 decimal places with 3.52. So I'm going to multiply by 100 to get rid of all my decimals. So it's going to be 86x plus 90 times 4 minus x equals 352. All right, so let's distribute that 90. So it's going to be 360 minus 90x equals 352. All right, and then 86 minus 90 is negative 4x. And if you subtract the 360, you get negative 8. So x equals 2. All right. All right, find the slope of the line. Remember, your equation of the line is, or the slope-intercept form of the line is y equals mx plus b. So we're going to get it in that form. All right, so let's see. This is going to be 5y equals negative 3x plus 16. Divide everything by 5. Y equals negative 3/5 x plus 16 over 5. And for the slope, it's just the number in front of x, positive or negative. So my slope here is negative 3/5. Now, in that same form, the b is your y-intercept. So I'm going to do the same thing. This is going to be y equals negative 2x minus 1. And my y-intercept is the piece on the back end, the negative 1. All right, now, 6, 7, and 8, you're trying to determine whether you got to find the slope twice, and you're trying to find if it's parallel, perpendicular, or neither. Okay, so first of all, this is x1, y1, x2, y2. Okay, and then my slope formula, if you remember, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just follow the formula, and all will be well. So my first slope is going to be 15 minus negative 1 over 6 minus negative 6. All right, so you got 16 on top because 2 negatives make a positive. All right, and 12 on the bottom, so that's going to be 4/3. All right, I don't know if it's parallel, perpendicular, neither until I find the second slope. So let's do that. So I got 3 minus 5, or sorry, 3 minus negative 5. Minus negative 5. 10 minus 4. All right, so that's going to be 8 over 6, which is also going to give you 4/3. Now, there's no test that needs to be done. If they're the exact same slope, and that means these are parallel. All right, number 7. All right, so I got my first slope. I got, let's see, 6 minus 4. I got 14 minus 10. All right, that's going to give me 2 on top and 4 on the bottom, so that's 1/2. All right, check out my second slope. I got 1 minus negative 1, 10 minus 11. That's going to give me 2 on top, negative 1 on the bottom. This is going to give me negative 2. Okay, so these are clearly not the same, so I want to check for perpendicular. All right, the easiest way to do that is to multiply your two slopes together. So I got 1/2 times negative 2, and that gives me negative 1. If it gives me negative 1, that's perpendicular. If it gives me anything else, it's not perpendicular. So these work out. This is perpendicular. All right, one more of this type. So number 8, we got first slope is negative 5 minus 1. All right, negative 6 minus 2. That's going to give me negative 6 on top, negative 8 on the bottom, which is going to reduce to a positive 3/4. Second slope, that's going to be negative 6 minus negative 2. All right, negative 11 minus negative 8. All right, so on top I got negative 4, and I got negative 3 on the bottom, which is going to reduce to 4/3, positive 4/3. Again, they're not the same, so I'm going to multiply them together and see what I get. It's only perpendicular if I get a negative 1, and I only get a positive 1, so this is not a thing, and that means this is neither. It's not perpendicular, and it's not parallel. All right, so that's how you do that. All right, on number 9, we're just going to multiply it out and solve. But if you notice, these parentheses are the same except for one's positive, one's negative inside. So that's the difference of two squares. So when I multiply this out, I'm not going to have a middle term. And so it's just going to be 49x squared minus 121. All right. On number 10, because it's squared, that means you're going to write it twice. So you got 2x squared minus 7, 2x squared minus 7. And you're going to FOIL it out. First times first, outer times outer, inner times inner, last times last. Okay, so that's going to give you 4x to the fourth. That's going to be minus 14x squared, minus 14x squared, plus 49. Combine the middle term, you got 4x to the fourth, minus 28x squared, plus 49. And that's it. All right, when you're adding and subtracting polynomials, if you're adding, the parentheses are there for show, so you can drop them and get to work. But this one's subtracting, so I'm going to distribute that negative through the back end. So I got 14x squared y squared plus 8y to the fourth. The negative, I'm going to distribute that negative, changing every sign behind it. So two negatives make a positive, so it's plus 15x to the fourth. I got plus 7x squared y squared and minus 8y to the fourth. Now, as you can see, I got an 8y to the fourth that is positive and negative, so that gets to leave. And then I have an x squared y squared here, and x squared y squared here. And so I need to combine like terms. So that's going to be 21 x squared y squared plus 15x to the fourth. And that's my answer. Okay, and if you put the 15x to the fourth in front, that's fine. As long as every term is positive, order doesn't matter. All right, number 12. You're doing the same thing, you're just distributing. So I'm going to take the 3x and give it to every term, and then I'll come back and get the 8y and give it to every term in the trinomial. So 3x times 2x is 6x squared. 3x times 9y is going to be 27xy. 3x times 1 is just 3x. All right, so I'm done with 3x. Let's do the 8y. 8y times 2x is going to be 16xy. 8y times 9y is 72y squared. And then 8y times 1 is just 8y. Combining the like terms. All right, so I got 6x squared. I got xy and xy, so 27 is 16. It's going to be 43, so plus 43xy plus 3x plus 16xy. And plus, I don't need the 16xy, plus 72y squared plus 8y. You have a mix of terms, x's and y's, so as long as you combine like terms, the order is not set in stone. All right, so there you go. All right, when you raise the power to the power, you multiply. So here's what we got. I'm going to say 2 cubed, p, 4 times 3 is 12, v to the 12th, s to the 6th. And then we have to figure out what 2 cubed is. 2 cubed is 8, so we got 8, p to the 12th, v to the 12th, s to the 6th. And that's my answer. All right, on 14. 45 divided by 5 is 9. I have more x's, y's, and z's on top than I do on the bottom. So when I reduce this, I'm not going to have a denominator. So this is simply going to be 9. 10 times 3 is 7, so it's going to be x to the 7th. 6 minus 3 is 3, so it's going to be y cubed. 3 minus 2 is 1, so it's just going to be z. So 9xz, y cubed, z to the first. That's my answer. All right, so for 15, we're doing long division. So I got 5x minus 2, 10x cubed plus 16x squared minus 33x plus 29. Now, when you are doing long division, you got to make sure every power is accounted for. So from highest to lowest, every power needs to be represented. In this one, my highest power is 3, and then it steps down to 2, and then to 1, and then a constant term, so everything's present. A good rule of thumb is that whenever your highest exponent is, in this case 3, I need one more term than I have my highest power. So in this case, my highest power is 3, so I need 4 terms. They're all there, so all is well. And that goes for the top of the fraction and the bottom of the fraction. All right, so when it comes to long division, I focused on the first term on the outside, the first term on the inside. I need to make them match. So 5x times what is 10x cubed? Well, that's going to be 2x squared. All right, once I know that, I'm going to multiply by everything out front. So 2x squared times 5x is 10x cubed. 2x squared times negative 2 is minus 4x squared. And then you're subtracting this entire line, so I'm going to change my signs. So that's negative, that's positive. This falls out. And so you got 16 plus 4, that's going to be 20x squared. The negative 33x comes down, and then you start the process again. 5x times what is 20x squared? Well, that's going to be 4x. All right, so 4x times 5x is 20x squared. 4x times negative 2 is negative 8x. change my signs. So negative, positive, that falls out. All right, so that's going to give me negative 33 plus 8 is going to be negative 25. X plus 29. All right, 5x times what is negative 25x? That's negative 5. So that's going to be negative 25x. Negative 5 times negative 2 is positive 10. All right, change my signs. This becomes positive. That becomes negative. That falls out. All right, so 29 minus 10 is 19. All right, because this is a polynomial and I'm out of terms to bring down, I am done. All right, it just so happens that this 19 is my remainder. And so I write my answer like this. 2x squared plus 4x minus 5 plus 19 over what I divided by, which is 5x minus 2. So that is my answer. 16. We have negative exponents. Well, the first thing you want to do is to deal with the negative, not the exponent itself, but the negative in the exponent. And so what that means is I'm going to change its position. So the 3 is going to come up, so it's 3 squared. And then the 2 is going to go down, so it's 2 to the 4th. 3 squared is 9. 2 to the 4th is 16. So 9 over 16 is my answer. Now, if that was able to reduce, you would reduce it, but you can't reduce this, so all is well. Okay, so scientific notation. You're going to multiply the number that's out front, 5 times 4. So you get 20 times 10. And then you're multiplying like bases, so you add your exponents. Negative 8 plus 3 is negative 5. Now, when it comes to scientific notation, the number out front, in this case 20, it has to be between 1 and 10, and 20 is not. So I need to take the decimal that sits behind 0 and move it. And so I took a big number and I made it smaller, so I'm going to add 1 to my exponent. And so because it doesn't fit the definition, I need to make that adjustment. And whatever adjustment I make, I adjust my power as well. So negative 5 plus 1 is negative 4. All right, so that's my answer. If I have to make an adjustment, I have to do that before I call it quits. When you're dividing, do the same thing. You do the numbers out front. 16 divided by 4 is 4. All right, times 10. Now this time, you're subtracting your exponents. So you're dividing like bases, so you subtract your exponents. Negative 3 minus 9 is negative 12. Okay? And the number out front is between 1 and 10, so I don't have to make any adjustments. That's just my answer. Now, for the next few problems, I'm just finding a GCF. I'm not asking you. All right, so I'm going to find the GCF. And so 24, x to the 9th part of the 9th, 64, 80. What can I pull out? Well, I can pull an 8 out. 8 goes into all those numbers. They all have at least an x, and so I'm going to pull out an x cubed. They all have at least a y, so I'm going to pull out the lowest y to the 5th. So 8x cubed, y to the 5th is my GCF. All right, so what's left inside? Well, 8 times 3 is 24. I got 3 x's on the outside. I need 6 more on the inside. I got 5 y's on the outside. I need 4 more on the inside. That's my first term. All right, 8 times 8 is 64. I already have 3 x's on the outside, and I need 2 more y's to make y to the 7th. Minus 10. I need 2 more x's on the inside to make x to the 5th, and then I already have y to the 5th on the outside. So that's my answer. All right, I really want that first term to be positive, so when I take the GCF out of number 20, I'm going to make sure I pull out a negative with it. First of all, 7, 35, and 21, I can take a 7 out, and again, I'm going to make it negative 7. And they have x to the 4th, x cubed, x squared, so I'm going to pull an x squared out. And so that's going to leave me with x squared plus, it's plus because I took out a negative, plus 5x, and then minus 3. Okay, and so that's my answer. All right, 21. In this case, my x plus 6 is in both terms, so that's my GCF. So I'm going to pull the x plus 6 out front, and I'll put the pieces together. So x plus 6 times x plus 14. That's my answer. Okay, on 22, you got 4 terms. When you got 4 terms, you factor by grouping. So I'm going to group my first 2 terms together and my second 2 terms together, and I'm going to find a GCF in each parentheses. All right, so in the first parentheses, I can take a 2 out and an x cubed, so it's going to be 2x cubed, and that's going to leave me with 4x cubed plus 3. And I would really like the 4x cubed plus 3 to show up again. All right, so let's see. I can take out a 5, so plus 5, and it's going to leave me with 4x cubed plus 3. So now I can treat the rest of this like I did on 21. I'll pull the 4x cubed plus 3 out and put the pieces together, 2x cubed plus 5. There you go. That's it. Now, on 23, every term has a y minus 8, so I'm going to pull that out first. Put the pieces together. That's going to give me x squared minus 11x plus 28. And I can factor that. So the y minus 8 is going to hang out. And I'm going to factor this trinomial. X squared breaks down to x and x. My second sign is positive, so both signs are the same as the first. So I got minus, minus. All right, so I got what times what is 28 and adds to 11. That'd be 4 and 7. So that is my final answer. All right, on 24, I'm going to take out a 5. So it's going to give me 3x squared minus 13x minus 10. Now, I want to factor a trinomial when that leading coefficient is a positive 1. I took a GCF out, but it wasn't enough to get me to the positive 1, so I got to do the AC method. So I'm going to take the 3, throw it to the back, and when I get there, I'm going to multiply. So this is going to be 5. The 5 is just going to hang out, and this is going to be x squared minus 13x minus 30. All right, factor that. You got x and x. My second sign is negative, so I got plus and minus. All right, what times what is 30 and subtracts to give you 13? Well, that's going to be 15 and 2. And because the 13 is negative in the middle, it's going to be minus 15 and plus 2. Now, because I started by multiplying by 3, I got to divide by 3. All right, so let's simplify this. It's going to be 5, x plus 2/3, x minus 5. Any denominator that's left after you factor, or after you simplify, you're going to move it in front of the variable. So that's going to go in front of the x. And so my final answer is going to be 5 times 3x plus 2, x minus 5. And with any factoring problem, if you ever want to check your work, you can multiply this back out, and it should give you your original problem if you did it correctly. All right, on 25, there is no GCF to take out, so I just got to go straight to the AC method. All right, so it's going to be x squared plus 2x minus 15. Okay, so that's x, the second side is negative, so it's plus and minus. All right, well, what times what is 15 and subtracts to give you 2? Well, that would be 5 and 3, and because the middle term is positive, it's going to be plus 5 minus 3. And once again, I started by multiplying by 15, so I got to divide by 15 to wrap things up. All right, I'm going to simplify. That's going to be x plus 1/3 and x minus 1/5. All right, I simplified, but both of my denominators stuck around, so I'm going to move them in front of the x and rewrite my answer. So it's going to be 3x plus 1, 5x minus 1. All right, there you go. That's my answer. All right. On 26, I'm going to factor out a negative 6. So let's see. Negative 6 is going to give me 6x squared plus 5x minus 6. Because I took out a negative, I got to change all my signs. And once again, the GCF was not enough, so I got to do the AC method one more time. All right, so I got negative 6 on the outside, x squared plus 5x minus 36. Negative 6. Let's see, x plus minus. All right, what times what is 36? And subtracts to give you 5. Oh, that'd be 9 and 4. And because 5 is positive, it's going to be plus 9 minus 4. And then once again, I started by multiplying by 6, so I got to divide by 6 here. All right, so it's going to be negative 6, x plus 3 over 2, x minus 2 over 3. Take my denominators that are left and throw them in front of the variable. Okay, so it's going to be negative 6, 2x plus 3, x minus 2. Or sorry, 3x minus 2. That's my answer. Now, 27, this is not as bad as it looks. This is technically a difference of 2 squares. This binomial is squared, and then 49 is a perfect square. So I can actually write this x plus 2 plus 7, x plus 2 minus 7. This would be the easiest way to do it, and then just clean this up. It'd be x plus 9, x minus 5. Okay, there's that. All right, on 28, I could take a 5 out, and so let's do that. I got 5, it's going to be 16x squared minus 24xy, and then plus 9y squared. Now, the first term and the last term, and the inside 16 and 9, those are perfect squares. All right, so this is one of my special forms. So that's going to be 4x. I take the square root of 16x squared, that's 4x, minus, I took the middle sign, and then the square root of 9y squared is 3y, so 3y squared. All right. If you don't know that, like, you could still factor this, but you would have to do the GCF method, not the GCF, but the AC method, and 16 times 9 is 144, so that gets a little cumbersome, but this is your answer. 4 times 4x minus 3y all squared. Okay. Now, I'm going to take a GCF out of 29. I'm going to pull an 8 out. And so let's pull the 8. That's going to give me 125 x cubed plus 64. All right, 125 and 64 are both perfect cubes. So I can say 8 times 5x plus 8. And then I'm going to use my formula to figure out what my trinomial is going to be. All right, so I got square my first term, so 5x squared is going to be 25x squared. I'm going to change my sign to a negative, multiply my terms together, so 8 and 5x is going to be 40x. and then square my last term, so plus 64. And there you go. Right? 30. This factors x to the fourth. Just split it in half. You get x squared and x squared. Because the second sign is negative, you got one of each, plus and minus. And then the factors of 9 that subtract to give you 8 are 9 and 1. And because the middle term is positive, it's going to be plus 9 minus 1. All right, x squared plus 9, that's nothing special. So I'm just going to bring it down. X squared minus 1 is the difference of two squares. So I got x plus 1, x minus 1. All right. There's that. And now on 31, I'm going to move everything to the same side. So x squared plus 12x plus 36 equals 0. Factor. Get x plus 6 and 6. All right, so this is x plus 6 all squared equals 0. Take square root of both sides. You get x plus 6 equals 0. So x equals negative 6. So when it's equal to 0, you have to solve for x. And so that's what we get. Now on 32, this is a rational expression, so this is going to be x minus 7 twice. X squared minus 49 breaks down to x plus 7, x minus 7. Cross out what you can. If it's the same on top as it is on the bottom, you get rid of it. And I'm left with x minus 7 over x plus 7. All right. On top, on 33, that's the difference of two cubes. So that's going to be y minus 6 times y squared plus 6y plus 36 over y minus 6, and I can get rid of the y minus 6. And I'm just left with this trinomial, y squared plus 6y plus 36. Okay. On 34, I got to factor everything. Okay, so on top, that's going to be x plus 1. It's going to be x squared minus x plus 1. On the bottom, I can factor out a GCF of x. So it's going to be x times x squared minus x plus 1. All right, on top, I got 6x. On the bottom, I can factor out a negative 48. And it's going to leave me with x plus 1. All right, so here's what I got. I can get rid of the x here. I can get rid of the x plus 1 here. And get rid of that trinomial. And I'm left with 6 over negative 48, which can reduce to negative 1 over 8. Okay. All right, so there you go. All right, 35. Now, when I divide fractions, remember I multiply by the reciprocal. So here, I'm going to say, I pull a 5 out, so that's going to be y plus 2. And pull a 4 out, that's going to be x plus 5. All right. So the x squared minus 10x plus 25 goes on top when I factor it, and that's going to be x minus 5, x minus 5. I got 4 terms on top, so I need to factor by grouping. And so I can take a y out, and that's going to give me x minus 5, plus 2, and that's going to give me x minus 5. So when I finish this, this is going to be x minus 5, y plus 2. And so now I can get rid of stuff. I can get rid of the y plus 2, and get rid of the x minus 5. And so I'm left with 5 times x minus 5 over 4 x plus 5. Okay. On 36, you need to find your common denominators. But before you can do that, you got to factor to figure out what all your parts are. So x squared plus 11x plus 28 gives you x plus 4, x plus 7. And then over here, you're left with x plus minus 7 and 3. So both of these have an x plus 7. So I need to multiply each of these by what they don't have. So the right side needs an x plus 4. Whatever you do the top, you do the bottom. And on the left, I need an x minus 3. All right, so that's going to be x minus 3, x plus 3, plus 5x plus 6 times x plus 4, all over my new denominator that has all 3 parts, x minus 3, x plus 4, x plus 7. And now I just need to clean up the top and simplify. Okay, so it's going to be x squared minus 9 plus 5x. Let's do this. That's going to be x squared plus 3x minus 3x plus 9, excuse me, minus 9, plus 5x squared, plus 20x, plus 6x, plus 24, all over x minus 3, x plus 4, x plus 7. Okay. All right, the 3's will cancel out here. X squared and 5x squared, that's going to be 6x squared. All right, you got 20x and 6x, it's going to be 26x, so plus 26x. And then you got 24 minus 9, which is 15, over x minus 3, x plus 4, x plus 7. And that's your answer. All right, when dealing with absolute values, you need to get the absolute value by itself first. So this is going to be 2x plus 9 equals 5. Now, the inside 2x plus 9 could be 5 or negative 5. So I'm going to set that up with two expressions. 2x plus 9 equals 5, or 2x plus 9 equals negative 5. All right, so you solve each of these to get your answer. 2x equals negative 4, so x equals negative 2. 2x equals negative 14, so x equals negative 7. So negative 2 and negative 7 are your answers. All right, on 38, you got to get your absolute value by itself first. So you got 7x plus 1 less than 5. And because it's less than, once you get the absolute value by itself and you see the inequality next to it, if it's an absolute value less than some number, that means it's going to be an and statement, which means I'm going to shade in between. So I can set this up like so. 7x plus 1 less than 5 and negative 5, like so. Subtract the 1 from both sides. It's going to be negative 6 less than 7x less than 4. Divide the 7, you get negative 6 over 7 less than x less than 4 over 7. And so I'm going to write my answer, negative 6 over 7, comma, 4 over 7, parentheses on both. And that's my answer. All right. On 39, and you clean up the inside first. It's going to be 2x plus 2 plus 4 less than or equal to, greater than or equal to 6. That's going to be 2x plus 6 greater than or equal to 6. All right, because it's the absolute value is by itself and I got greater than, that means I'm going to shade in opposite directions. All right, so I got to set it up a little differently. That's going to be, let's see, 2x plus 6 is greater than or equal to 6, or 2x plus 6 less than, I changed the inequality and I changed the sign. So it's going to be less than or equal to negative 6. All right, and then solve each of these. So it's going to be 2x is greater than or equal to 0, so x is greater than or equal to 0. 2x is less than or equal to negative 12. X is less than or equal to negative 6. Okay, so if you were drawing a graph, then it would look like this. You would have negative 6 on the left, 2 on the right, and then I would bracket on both, shade in opposite directions. So it looks like that. And so when I write my interval notation, it's going to be negative infinity to negative 6 with a bracket, union, bracket on 0 to infinity, and parentheses on both the infinities. All right, on 40, I got to take the cube root of negative 8, which is simply negative 2, and then the powers, the cube root of a cube is just going to cancel out, so negative 2 times x plus 1, and that's your answer there. On 41, I got to deal with the negative first. The negative says I'm going to flip that fraction, so I got 64 over 27 to raise to the 1/3 power, and then the 1/3 says I'm going to take the cube root of the top and the bottom. The cube root of 64 is 4, the cube root of 27 is 3, so my answer is 4/3. 81 is not a perfect cubed, so I need to split this up and simplify. All right, so 27 times 3 is 81, and 27 is a perfect cubed. 3 doesn't go into 11, but 3 does go into 9, so I can split the 11 into x to the 9th, x squared, and then y to the 9th. 3 will go into that. And so in the front, I got everything that I can take the cube root of, and in the back is everything that's going to stay inside. And so the cube root of 27 is 3. 9 divided by 3 is 3. 9 divided by 3 is 3. So I got 3x cubed y cubed, and then I have the cube root of 3x squared. And that's my answer. All right, on 43, I got to simplify each of these fractions, because just like fractions, or I got to simplify each radical. So just like fractions, you got to get a common denominator. With radicals, you got to get a common radical before you can add and subtract. So 128 breaks down to 64 times 2. 3 breaks, is on the outside. 98 breaks down to 49 and 2, plus 4. 72 breaks down to 36 and 2. Now 64, 49, 36 are all perfect squares, so I can take the perfect square. I can take the squares here. So the square root of 64 is 8, and there's already an 8 out there, so 8 times 8 is 64. So I got 64 square root of 2 minus the square root of 49 is 7. 7 times 3 is 21, so I got 21 square root of 2 plus the square root of 36 is 6 times 4 is 24, so I got 24 square root of 2. All right, so 64 minus 21 plus 24. All right, that's going to give you 67 square root of 2. All right, there you go. Now on 44, you can divide these two. All right, so I'm going to open this up by saying 250 a to the fourth b to the sixth over 2a. And that's going to simplify to the cube root of 125 a cubed b to the sixth. All right, both of those are, or rather all three of those are perfect cubes, so everything's going to come out. So it's going to be the cube root of 125 is 5, and then that's going to be ab squared. All right, this means you're going to write it twice on 45, so you got 3 square root of 5 plus 5. I'm going to write it twice. All right, fold it out. So this can give me 9 square root of 25 plus 15 square root of 5 plus 15 square root of 5 plus 25. The square root of 25 is 5. 5 times 9 is 45, so it's going to be 45 plus 30 square root of 5 plus 25. And then 45 and 25 is 70, so you got 70 plus 30 square root of 5. Okay. On 46 and 47, you're rationalizing the denominator. On 46, I need to produce a perfect cubed underneath. So 5 to the first, I need 125, so I need 2 more 5s, so I'm going to multiply it by 5 squared. So when I multiply these together, I get 5 cubed, which gets to come out. Okay, so 5 squared is just 25, so I get the cube root of 25. And since it's the cube root, I can't do anything with that. And then by multiplying the bottom, I get a perfect cube inside, so that just leaves me with 5. So my final answer is the cube root of 25 over 5. Now on 47, you're going to multiply by the conjugate. So that's going to look like this. 7 plus radical 2. 7 plus radical 2. Now this allows all your radicals in the bottom to go away. And on top, I'm just going to distribute. So 4 times 7 is 28 plus 4 radical 2. And then 7 times 7 is 49. Radical 2 times radical 2 is 2. So 49 minus 2. And then I just clean up the bottom. So it's going to be 28 plus 4 squared root of 2 on top. And then 47 on the bottom. Okay, and then our last three problems, we're going to graph our equations. 48 is pretty straightforward. It's in slope-intercept form already. So the 3 is my starting point, so I could go from 0, 0, go up 3, 1, 2, 3. And then my slope is negative 1/2, so I'll go down 1, right 2. That's my second point. And then I connect the dots, draw my line. Okay. And that's all you're doing there. On 49, this is a horizontal line. So y equals negative 5. All right, I got y equals negative 5, and then I draw a horizontal line straight through it. That's it. Now 50 is a bit more tricky, and you could solve this for y, or you could do y-intercepts, or not y-intercepts, but both intercepts. So if you're dealing with the x-intercept, you can let y be 0, so you get negative 6x minus 12 times 0 equals 24, which is going to get rid of that y term, and so you get negative 6x equals 24, x equals negative 4. And so I'm going to come over here, x equals negative 4. Now I can do the same thing for my y-intercept and let x be 0. So that'd be negative 6 times 0 minus 12y equals 24. It's going to get rid of the first term, and so I get negative 12y equals 24. So y equals negative 2. So I plot y equals negative 2. That's right here. And then once again, I connect my dots. And that's it. I've done the job. Now, it's better to do it this way with the intercepts, because if you try to get y by itself, you're going to end up with some fractions, both as a starting point and your slope, which can get a little convoluted. And nobody likes working with fractions. So save yourself some headache and just find your intercepts like this, and that'll be it. All right, guys. I hope you found that helpful, and best of luck on the final.